How you doing? I'm Mr. Rose, and today we're going to talk a little bit about electric forces and electric fields. We got me, we've got our friend Albert Einstein in the corner, and we're doing this totally on the cheap because I couldn't get both cameras to work. So, what I would like you to do is take a look at this question to start. Give it a pause, give it a read, write down all of our given information. And now I'm going to get to it. So, we are looking for what must a force be between 2 points. This should be a pretty easy question. Q1 and Q2. What must the distance be if there's some distance apart? So I'm now looking at our given information. I've got a Q1. I've got a charge 2. It doesn't tell me the orientation, but I have to have them obviously linear apart. They told me the charge of Q1 was 26.0 microcoulombs. They told me the charge of Q2 was negative 47.0 microcoulombs. Positive and negative, I know there's going to be an attractive force between those two. So this would be F1 on 2. This would be F2 on 1. And very simply put, they told us the force was F equals 5.70 newtons. So this is just a straight plug and chug question of F equals 1 over 4 pi epsilon 0 times Q1, Q2 divided by r squared in the r hat direction. Now I know it's linear, so my r hat again is just going to be something that you can't see, something that just completes my unit vector form. I know micro is something times 10 to the negative 6th, nano is times 10 to the negative 9th. So I can plug right in, but we're in our AP class, so we're not going to do that. We're going to rearrange for variables. So I'm going to say that. Actually, one thing to note. A lot of you will know this as K, the constant K, 9 times 10 to the 9 Newton meter squared per Coulomb squared. Again, we're using this 1 over 4 pi epsilon not as a common constant that we'll use throughout. This is going to make things easier later, where epsilon naught is a permittivity of free space. If you want to insert K here, you can. It might make your math easier. I'm not going to do that. So I have 4 pi epsilon 0 times the force is equal to Q1, Q2 over r squared. We're looking for the distance, which means r is equal to the square root of Q1, Q2 over 4 pi epsilon 0 times the force. This is my final equation. We know I'm looking for a magnitude because I can't take the square root of a negative number, so make sure you do that. I'm going to speed this part up, but through the movie magic, we get r is equal to 1.38 meters is what I got. Nice and simple. I'm going to do these in segments, so that's all I have for you right now. If you like what you see, please feel free to like, click, subscribe, make any comments, and you'll see me here next time.